Tina slowly. We be working all day long, the push us bunny. We ain't playing no games. Sabatavi, Gani.
Good day, grade 11. I hope you are good. Today we are doing solve for x again, but this one we are dealing with solve for x that requires us to take out the common factor. So remember, when we are dealing with the solve for x that we need to take the common factor, we have to look in our exponents and see if all the bases are the same, and look for the coefficients of the variable if they are all the same, so that we can see what is common between them. Remember, if you want to see that you are required to take out the common factor, so between the bases you must have the sign which is a positive or negative. So once you see that you have a positive or negative between the bases, you just know that I need to take out the common factor. I need to find what is common between them, because we cannot apply the laws or the laws of exponents. So the laws of exponents only work whenever you have the multiplication or the division between the bases. So here, let's see how do we tackle number 1. Remember, you can pause the video and try to attempt this question on your own. Right, we have here 2 to the power x plus 2 plus 2 to the power x equals to 20. Good people, can you see that between my bases, what do I have? I have the sign. So I need to take out the common factor. So I'm going to split this one so that I can see the common factor, because we cannot change this one. It will remain as it is. So if I split 2 to the power x, it's going to be 2. It's going to be 2 to the power x times 2 to the power 2 plus 2 to the power x equals to 20. Now, can you see what is common here? So this 2 to the power 2x is common. Remember, but the coefficient here was 1. So now the coefficient, our coefficient, they are not common here. So the only thing that is common here is 2 to the power 2x. So I'm going to take out 2 to the power 2x. Remember, I have to open my brackets if I take out the common factor. Remember, we're having binomial here. I must have 2 terms also inside the brackets. So now I'm left with 2 to the power 2x plus 1 equals to 20. Now, this is 2 to the power 2x here. This is 2 to the power x. 2 to the power 2 give us 4. 4 plus 1 give us 5 equals to 20. What must we do, grade 11? Yes, we divide both sides by what? By 5. So we divide, so this will cancel out. So now we have 2 to the power 2 to the power x here. Then 20 divided by 5 give us 4. Now 4, guys, is a composite number, so I have to change 4 to find the prime base of 4. So I drop again 2 to the power 2 to the power x. Then this one will change to be 2 to the power 2. Now, whenever you have the bases that are the same, because your aim here is to get a single power here and also a single power on your right side and the left side. Now the bases are the same. Now we can conclude that x is equals to 2. We equate the exponents when the bases are the same. Right, let's see what you have. The next question, I'm going to answer it here, guys. So the next question, okay, we won't do this one, number 2, because there's no common factor here. Hence, we put star here. So I'm going to take number 3. Number 3, we're given 3 to the power x minus 3 to the power x minus 2 equals to 72. Same approach, guys. So I have 3 to the power x minus 3 to the power x minus 2 equals to 72. So the aim here, guys, because between my bases I see that I have the sign, so I have to take out the common factor. So I need to find out what is common here. So I will drop this one as it is because I cannot change anything here. Minus, if I split this one, it's going to be 3 to the power x times 3 to the power negative 2 equals to 7, 2. So what is common here, good people? Yes, we can see that 3 to the power x is common. So I'm going to take out 3 to the power x and I open my bracket. So we're having two terms here. I must have two terms inside the brackets. So the coefficient here was 1 because our coefficient was not common. So I have 1 inside minus 3 to the power negative 2. We have equals to 7, 2. Remember, you have to simplify whatever you have inside the brackets. This is 1 minus, this power, it tells you that I'm in a wrong position. So it's going to be 1 over 3 to the power 2 equals to 7, 2. So now I have 3 to the power x here, 1 minus 1 over 3 squared give us 9. Then I close the brackets, equals to 7, 2. Right, if you simplify this one, you can press your magic machine or your calculator. So here you are going to get 8 over 9 equals to 7, 2. So remember guys, we are solving for x. I needed this one to be a single power. So what must I do? I have to divide by 8 over 9, or just multiply by the reciprocal of this fraction, maybe multiply by 9 over 8 both sides. So if I divide both sides by 8 over 9, then I will put the division 8 over 9. So this will cancel out this one. Now we are left here on this side by 3 to the power x equals to, then good people, 72 divided by 8 over 9, you will get 81. So that's 81. So we need to find the composite. This 89 is a composite number. We need to find the prime base here. It's simple guys. I showed you how to find the prime base here. You just press 81, then you press equal sign, then you press shift, then you come to this button. In fact, you see that is 3 to the power 4. So now we can change this one to be 3 to the power x equals to 3 to the power 4. Now the bases are the same. So now we can conclude that our x is equals to 4. Because when the bases are the same, you equate the what? The indexes. Okay, let's see what we have. Number 4. Same thing guys. Number 4, we have 5 to the power x minus 2 plus 5 to the power x plus 1 equals to 126. So I'm going to answer this question guys here. The approach is still the same. Remember, you can pause this video and try to attempt this question on your own. So we have this question here equals to 126. Remember guys, I repeat again, immediately I see plus or minus between the bases, I have to take out the common factor. So here, and also if you see that your exponents are the same, because here we have x and here we have x. Now the exponents are the same and I have the sign between the terms, so I have to take out what is common. So then I will say this is 5x times 5 minus 2 plus 5x times 5 plus 1 equals to 126. Now guys, do you see that this is minus 2, good people? Can you see that your bases are not the same? I mean your coefficients are not the same, but we have something common here, which is 5 to the power x. So I take 5 to the power x as my common factor equals to 126 on this side. So if I take out 5 to the power x, then I'm left here with 5 to the power negative 2 plus, then we keep this sign. Here we have 5 to the power 1. So we drop 5 to the power x again. Remember, you can press this one on your calculator. This is 5 to the power negative 2. If I say 5 to the power negative 2 plus 5, we get 126 over 25. So here we can say this is 126 over 25 equals to 26. What must I do, good people? Yes, I can multiply by 25 over 126 both sides, or just simply divide by 126 over 25 both sides. So this will cancel out. Now we have 5 to the power x here equals to, remember, if you divide this one, you will get 25 because it's the same as 126 divided by 126 over 25. Then it's 126 times, then you do the reciprocal here. It's going to be 25 over 126, so this would cancel out. So then we have this one. Now we have to find the prime base of 25 because 25 is a composite number. So it's simple now. It's going to be 5 to the power x equal to 5 to the power 2. Now, the bases of the word are the same. Now, we can conclude that our x is equals to 2. So that's your final answer for this question. That was cheap. That was very cheap. So let's see what do we have number 5. So number 5, guys, we have 3 to the power x plus 1 minus 3 to the power x minus 1 minus 24. Guys, if you want to take out, if you have to take out the common factor, you must see if your exponents are the same and also you have something that is common or the sign between the bases. So I can see that I have the sign between the bases. Then I have to look if my exponents are the same. I have x here, I have x here. So which means I have a common factor. But if it was 2x on this side and this is x here, we were not going to take out the common factor. We have to apply another method. So let's take this one. But we are going to talk about that on the next video. So we have 3 to the power x plus 1 minus 3 to the power x minus 1 equal minus, oh sorry, this is minus, guys, 24 equal to 0. So remember, there's a difference between this one and this one. Then here we were having only the bases here. So which means 72 was already on this side. So if I want to take out the common factor here, I must make sure that I transpose the constant to the other side. So if I transpose this negative 24 to that side, we know that the sign is going to change. So I'm going to have here 3 to the power x plus 1 minus 3 to the power x minus 1 equals to 24. So now we have to split this one using law number 2. So this is going to be 3x times 3 to the power 1 minus 3 to the power x times 3 to the power negative 1 equals to 24. Right. Now, what is common here, good people? Now we can see that 3 to the power x is common here. We are going to take 3 to the power x as our common factor. Now, if I take this one, I remove this one, take it as my common factor. Now I'm left with this one with 3 to the power 1. Then I keep the sign minus. Then I take this one as my common factor. I have 3 to the power negative 1. Then I have to close my brackets equals to 24. Right. Then I have here 3 to the power x and 3, because 3 to the power 1 is same as 3, minus this one. It tells you that I'm in a wrong position, which means it's going to be 1 over 3 equals to 24. Are you happy? Yes. This is easy. Now you can press this one in your calculator. 3 minus 1/3, you get what? 8 over 3. So now we have 3 into 8 over 3 equals to 24. Remember, good people, the aim here is to have the single power here and also the single power on my right side. So what must I do? I must get rid of 8 over 3. So I have to divide both sides by 8 over 3. Then divide by 8 over 3. So this will cancel out. Now I know that you are smiling because you see that you are close to the answer. So now you have 3 to the power x here. Then if I say 24, divided by 8 over 3, can you see that? How do I press my calculator? Because I know that most of the learners, they confuse. They say 24 divided by 8 divided by 3. You see, you get 1. So you can say 24 divided, you press this button, the fraction button, then you have 8 over 3. So you see, it's 9. So 9 is a composite number, good people. Now we have to change this one to a prime base. So now I will have 3 to the power x equals to 3 to the power 2. Now the bases are the same because our aim was to have a single base here and a single base here. So now the bases are the same, so we can conclude that our x is equals to 2. Right. Now we are doing the last question, guys. So this one, the last question, I'm going to do it here. Hope that you understand. So we are having here number 6. We have 3 to the power x plus 2 minus 3 to the power x minus 1 equals to 26. Remember, guys, once we see that there's a minus or positive between the bases, we need to take out the common factor, but I have to perform another step again. I have to look at my base, my powers. I have the same power or the same variable here, x and x again. So which means I have the common factor in this case. So I'm going to split this one because in order for me to see the common factor, so that I can see the common factor, this is 3 to the power x times 3 to the power 2 minus 3 to the power x times 3 to the power minus 1 equals to 26. Yes. So what is common here? We can see that 3 to the power x is common again here. Then open the brackets. If I take this one as my common factor, now inside I have 3 to the power 2. Then I keep this sign, minus. Then I take this one as my common factor. Now I have 3 to the power negative 1. Then I close my brackets, equals to 26. Right. So now let's fix, guys, this. I have 3 to the power x equals to 3 squared give me 9 minus. So this means 3 to the power negative 1. It tells me that I'm in a wrong position. So it's going to change to be 3 over 3 to the power positive 1. Then I close the brackets, equals to 26. Now I have to simplify this, what I have inside the brackets, so that I can have the single power on my left and the right. So 9 minus 3, 9 minus 1/3. What do we have? It's 26 over 3. 26 over 3. Then I close my brackets. Then I have here 26. So what must I do, good people? I have to divide both sides by what? By 26 over 3. What I did on my left side, I must also do it on my right side. So 26 over 3. So these cancel out. Now I have 3 to the power x equals 2. Then if you say 26 divided by 26 over 3, you will get 3. Now the bases are the same, but we all know that, guys, the power here is always 1 if it is not written. So now the bases of the what are the same. So now we can conclude that now we see that the bases are the same. Now we can conclude that our x is equals to 1. That's your final answer. Remember, you can verify your answers here. Whatever answer you got here, you can take this one and substitute wherever you see x and see if you get 26. If I can say 3 to the power, then I see x. Then I will put this answer 1 plus 1 here. Then I have minus here 3. Then I have 1 minus 1. You see that is 26, which means my answer is correct. Right. So that was our last question, guys. Thanks for watching. If you didn't subscribe, please don't forget to subscribe. Like the video. Give us thumbs up, guys. You are more than welcome to comment. Share the video. Thank you so much.